Okay. Now the root test, okay? It's got similar rules to the ratio test. If the nth root of the absolute values is less than 1, it's absolutely convergent. If the nth root equals 1, the test is inconclusive. And if it's greater than 1, it's going to be divergent. Okay? So it's basically the same rules as the ratio test. Right? And now, when are you going to use the root test? If you have something that's to the power of n, you can use the ratio test on it. There's nothing wrong with that. But sometimes it's easier to use the root test. So let's say you had something like this. Okay. So this is raised to the power of n. So you can look at this and say, oh, well, maybe the root test would be a good idea. All right. So if I take the limit now as n tends towards infinity of the nth root of the absolute value of the natural log of n, put that parentheses right there, divided by n, and then raised to the nth power, okay, that would just equal the limit as n tends towards infinity, right? So the nth root is going to cancel the n, and so that would be the natural log of n divided by n. Okay. Now, I can say this guy goes to infinity, this guy goes to infinity. That would equal the limit as n tends towards infinity. The derivative of the natural log of n would be 1 divided by n, and the derivative of n is just 1, and so that would equal 0, which is indeed obviously less than 1. So, by the root test, the sum n which equals 2 to infinity of the natural log of n divided by n and raised to the nth power is absolutely convergent. All right, let's do another one. So, let's say we had something like, let's say the sum n which equals 1 to infinity of n divided by 2n plus 1, and then raised to the nth power. Okay, so we got an nth power. So the root test seems like it's going to be a good method for this one. So let's take the nth root of this, the limit of it. So that would equal the limit as n tends towards infinity of n divided by 2n plus 1. Okay, so let's divide by the highest power on this. And so that would equal the limit as n tends towards infinity of 1 divided by 2 plus now 1 divided by n. Okay, that's going to go to 0. And so this is going to become 1 divided by 2, which is indeed less than 1. So, by the root test, the sum n which equals 1 to infinity of n divided by 2n plus 1 raised to the nth power is absolutely convergent.